different ways of setting up problems, different ways of going through it. You have to be able to make a decision as far as what's more efficient. Okay, what's the efficiency of certain methods versus others as far as quadratics? And there is a time and a place for each one of them. And if you fall into the same category of doing the same thing over and over and over again, sometimes it works, sometimes it doesn't work for you. Sometimes you spend too much time on one method versus another, and especially if you've got tests and stuff, there's usually a time and a place to make them work. For example, so when you think about solving the quadratics, we have factoring, complete square, and then quadratic formula. I guess you can also say graphing, but that's the same thing as factoring. So when do you choose what? And that's kind of the big idea here. If you can make a decision when you're looking at a quadratic, any one of these quadratic problems, and make a decision within the first 3-4 seconds of it, then you're doing fine. If it takes you longer than 5 seconds to decide what to use, what method to use, that's weird. So here's what I'm thinking. Factoring, when it's easy. If you think about it, if you look at something, you know what times what equals 12, you add together to get -1. Or -12 and -1. What times, if you have, I'm trying to think of an example. Let's think of an example off the top of my head. Like x squared minus x minus 12 equals 0. If you can see that and go, oh, I know what that is. I know what my factors of 12 are that add to a -1. I can do that real quick. What are they? 3 and -4. Okay. That's like an easy, quick factoring thing. I can say, oh, yeah, I can do this. It's x plus 3. It's x minus 4. That gives me zeros where and where? -3 and 4. That's something you could do real quick off the top of your head. Go for it. Okay? Do it. Now, when I look at completing the square, now, when we first looked at completing the square, it seemed very, like it took forever, but after you got going on it, that was really easy, isn't it? It's the same thing over and over and over again. I love completing the square. And then next week, when we have a day that we actually are here after all the PSATs and all that other stuff that's going on, we'll start talking about what are called conic sections. Conic sections we look at in terms of, again, parabolas, but our parabola is going to fall over because they can't. So we'll have all these different formulas of what are called conic sections, or standard forms of conic sections, parabolas, ellipses, hyperbolas, and circles that we will use completing the square a lot to set them up. Okay. So completing the square is, and also when our b value, let's say it this way, not factorable and b, is an even number. Because when you take half of the number, it's a lot nicer when it's an even number. Otherwise, you have to deal with fractions. Again, you saw that the fractions you had weren't terrible, but it's a lot nicer if that b value is 6. Yes, sir. Yes, sir. That's the whole idea. If it is factorable and you forgot, what something it adds together to get something else, there's nothing wrong with that. What's going to happen with completing the square then? You'll get like 5 plus or minus 3. That might have been your answer. You know what I mean? As you wrote it out, so you could have 8 and 2. Those could have been your 2 solutions. It's how it gets set up is up to you. If you're comfortable completing the square and you just say, screw you, factoring, I don't want to do it, that's fine. That's fine. It really is. I'm cool with that. And then the last one is quadratic formula, and I would say this when all else fails. Seriously. If you've got fractions, if you've got decimals, you don't want to deal with all the Just use quadratic formula. It'll get you there. It'll get you there. What's that? Oh, stuck a knife into his brain. So, for example, if I'm looking, oops. That's right, 'cause we're running short on time. I just kind of briefly said something about it on Thursday because we were trying to bum rush through everything. When you're dealing with the discriminant, what they ask you a lot of times, and this is a very common SAT, ACT style question, they'll just say, how many and what type of solutions does the following have? And it's basically saying, hey, find the discriminant and figure it out. So the discriminant is this part. The discriminant is the b squared minus 4ac. That part is just the number that's underneath the radical. Okay? You don't square root it, you don't do anything like that. That's just the discriminant. This can have three possible solutions. It's either positive, negative, or zero. The discriminant only can be three things: positive, negative, or zero. If the discriminant is positive, you have two real solutions. How many and of what type? You have two real numbers: 7 and -3. Negative. If the discriminant is negative, that means you have two imaginary. Because when you take the square root of a negative, you get an imaginary number. Before, when you guys first learned about if you had a negative with the square root, remember how you said no solution? Now we know there's solutions. They're just imaginary. You can think about them, just don't talk about it. And then lastly, if the discriminant is 0, you have one solution. That's when it lands on the x-axis, where the vertex itself is on the x-axis. That's when you have jump squared, x minus 1 quantity squared. It has one solution. It's at 1. That's where it came from. Okay. I know we said that real quick on Thursday, but I just don't know if we actually wrote it out. So, like I said, I think I knew that I was going to be gone on Friday, trying to bum rush through as much of it as possible, and went up. Excuse me. Any other weirdness on there? Nope, that's 6. I want the 5, 6. Now let's do this. Solve by any method. You didn't do those because you stopped on the other side. Yeah, we did that. Let's do these for tonight. Solve any method. You make the decision as far as what you want to do. Do it. It's not fitting you into one form or the other. What is that? 5.6 would be 46 to 55. Let's do those 10. We called it there. Tomorrow we'll have Miss Yule will be in. She's gonna present to you guys a couple of the last little bit of things as far as how do you write when you're given a point and a vertex, or if you're given the zeros, how do you come up with the equation? It's actually really simple. You guys have done point slope stuff before, where you're given a point and a slope, write it in the slope intercept form by distributing out. It's kind of the same idea, but it's got a quadratic to it, so it's not terrible. It's kind of procedural, just knowing your forms. Yes, ma'am. This is I'll put the PDF on there. It's on page 296. So if you give me a sec, I'll re-upload that PDF file to today's date. Because right now it's on Fridays. 46 to 55. Let me write this down so I don't forget, and I will put it. I said 296? I'll post this up there.